Automated essay scoring has made massive strides in the last decade, but if you look closely at the literature, there's a glaring bottleneck. Nearly every state-of-the-art model is benchmarked on one dataset, ASAP. And while ASAP has driven progress, it's creating a false sense of security. Models trained on it don't generalize well, they offer students almost zero actionable feedback, and their evaluation setups are fundamentally flawed. Today, we're breaking down a new paper that tackles this head-on. It introduces ICLE++, a corpus designed to push AES research forward by introducing fine-grained trait scoring, controlling for confounding variables, and finally giving us a realistic testbed for cross-prompt evaluation. Let's start with why ASAP is hitting a wall. First, generalizability. ASAP consists of essays from native English-speaking U.S. students in grades 7 through 10, written under strict time limits. In those settings, essay length becomes a massive confounding variable. Models quickly learn to correlate word count with higher scores, because students who write more tend to score higher. But in real-world or academic settings, length is often controlled or unrestricted. Second, feedback granularity. A holistic score tells you an essay is bad, but not why. Early heuristic models like eRater broke scores into traits, but modern learning-based models mostly ignore them. The closest thing we have, ASAP++, adds trait scores, but it's too coarse. It lumps everything about content into a single content bucket. That's useless for feedback. If your content score is low, you have no idea if it's because your thesis is muddy, your arguments are weak, or your ideas aren't developed. Third, cross-prompt evaluation. ASAP mixes persuasive, narrative, and source-dependent essays. Evaluating cross-prompt models by training on one prompt type and testing on another is methodologically messy. A good persuasive essay follows a completely different rubric than a narrative one. It doesn't make sense to mix them. This is where ICLE++ comes in. It's a curated corpus of persuasive essays, written by university-level English as a foreign language learners from 16 countries. But the real innovation isn't just the demographic shift. The authors controlled for essay length, keeping nearly all essays between 500 and 600 words. This removes length as a confounding variable, forcing models to actually evaluate writing quality rather than just token count. More importantly, ICLE++ introduces 10 fine-grained, human-annotated traits that break down exactly what makes a persuasive essay strong. Instead of ASAP++ single content label, ICLE++ splits it into thesis clarity, argument persuasiveness, development, and coherence. It also tracks non-content traits like prompt adherence, organization, cohesion, sentence structure, vocabulary, and technical quality. Every essay gets a holistic score from 1 to 4 in half-point increments, plus scores for all 10 traits. Let's talk about how these traits are defined and scored. The annotation scheme was built in consultation with freshman writing instructors. Each trait uses a 4-point rubric. For example, argument persuasiveness measures how convincing the essay is for its thesis, while development checks if main ideas are backed by elaboration and examples. Coherence and cohesion are deliberately separated. Coherence is about the logical flow and transitions between ideas, while cohesion focuses on the actual linguistic devices, like transition words and phrases, that link sentences. Interannotator agreement, measured with Krippendorff's alpha, sits comfortably above 0.6 across all traits, with overall quality hitting 0.755. The authors note that half-point scoring introduces natural disagreement, but structured discussions and clearer half-point rubrics resolved most conflicts. Interestingly, they found that content traits like persuasiveness and development correlate most strongly with holistic quality, while technical quality and vocabulary matter less in the final score. A linear regression on the traits confirms this. Persuasiveness carries a weight of 0.26, development 0.19, while thesis clarity sits at just 0.04. Now let's look at the experiments, because this is where the technical meat lies. The authors tested state-of-the-art AES models on both ASAP and ICLE++ under 2 settings, within prompt and cross-prompt scoring. They used models like Kumar et al.'s CNN-LSTM with attention pooling, which extracts sentence-level representations via CNNs and aggregates them document-wide with LSTM attention. They also used Udo et al.'s BERT plus handcrafted features architecture, and PMAES, which uses prompt mapping contrastive learning to align essay representations across different prompts. In PMAES, source essay representations are mapped to target prompts via dot product similarity with learnable parameters, then optimized with a contrastive loss to pull aligned pairs together and push misaligned ones apart. The results are revealing. First, models trained on ASAP perform significantly worse on ICLE++, dropping quadratic weighted kappa scores by nearly half. QWK is the standard agreement metric for AES, and it penalizes larger errors more heavily than simple accuracy, so this drop confirms a real generalization gap. Second, when they analyzed feature importance, the shift was stark. On ASAP, top features were surface-level counts like word types, character length, and sentence count. On ICLE++, readability metrics like Coleman-Liu, flesh reading ease, and SMOG index dominated. This proves that once you control for length and native speaker bias, models have to rely on actual linguistic complexity and readability, not just volume. Third, and this is crucial for the field, adding trait scores actually improved cross-prompt holistic scoring, even when the predicted traits were noisy. For within-prompt scoring, the results were mixed, likely because the models struggled to accurately predict the fine-grained traits on this new dataset. But when they fed the model gold standard trait scores, QWK jumped dramatically, proving that trait information genuinely helps holistic prediction when available. So what does this mean for the future of automated essay scoring? ICLE++ isn't just another dataset. It's a methodological upgrade. By controlling for length, focusing on a single essay type, and introducing fine-grained content traits, it forces AES models to learn what actually matters in writing quality. It exposes the brittleness of models trained on native, time-pressured, length-correlated data, and it provides a realistic framework for cross-prompt evaluation. The authors have open-sourced the annotations, which is a massive win for reproducibility. As we push toward more robust, pedagogically useful AI grading systems, fine-grained trait modeling isn't a luxury anymore. It's a necessity. If you're working in AES or educational NLP, this corpus is exactly what the field has been waiting for. Thanks for watching, and I'll see you in the next one.